Okay, now we're going to start with problem 4 on this test review. I went ahead and have written out part A of 4. This is where we're looking at composite functions. This is basically a composite function f of g of x. What this says is you've got an f function, and in this case I have f of u up here. F of u equals u minus 3 over 2. And this says go to your f function, and every place you have a u, you insert the whole g function, which is square root of x. So it's really not that hard. So f of g of x is go to your f function, u minus 3 over 2. But I'm not going to write u. In place of the u, I'm going to substitute the g function, which is square root of x. So this would be square root of x, which is the u, minus 3 over 2. And that actually is your answer. Really not very difficult. So they gave you a second problem. They said f of u is, there's actually a typo in this review, because the typo says x squared. Should be u squared. I'll have to fix that for future classes. And then they say g of x is 2 over x. So once again, they're wanting the composite function. In some books, they write the composite function with this like this empty circle. But in our book, they just simply write it like this. Although whenever I do these problems, I automatically always change it to f of g of x. So this is notation I like, but a lot of books will show it that way also. Anyway, so f of g of x, go to my f function. In this case, every place I have a u, I'm going to replace it with this g function. So it's u squared. So it's 2 over x squared minus 1. Now, to be honest, I'd be okay with this, but maybe the book or some people would want you to multiply out these parentheses, so 4 over x squared minus 1. All right, not too difficult. All right, now starting with problem 5, we get into a little bit of stuff that's more now preparing us for calculus. We have a couple limit problems. It says find the indicated limits, and for this one it says the limit as x approaches negative 2, x squared plus 2x minus 1. What I told you in class was when you're trying to find the limit of an expression, the first thing I suggest you do is you just go ahead and plug the number in for the variable. And if nothing strange or goofy happens, like you don't have zeros in the denominator or other goofy things, then that's basically your limit. So let's see what happens. If I plug in minus 2 for x here, I'd get minus 2 squared, which is 4. 2 times minus 2 would be minus 4, and minus 1. Basically, if I plugged in negative 2 and for x here, this whole thing equals negative 1. If that happens, if you just get a number, then basically that's what the limit is. Remember, the limit says as x approaches negative 2. And with some problem, the whole idea of approaching becomes important, because we're going to have some problems where, for instance, oftentimes x, say, could not be negative 2, or you would have a problem. So what you're saying is, okay, we won't make x negative 2, but let's see what happens when x gets really close to negative 2. Now for this kind of expression, it doesn't really mean a whole lot, because it's perfectly fine for x to be minus 2. So we just plug it in and say there's your limit. Now I assume some of these problems are going to be a little trickier. So here the limit as x approaches 2 of x squared minus 4 over x minus 2. So once again, first try is you just go ahead, plug in 2 for x and see what happens. So when I plug in 2 for x here, I get 2 minus 2, which is 0. And right away I say, oops, that's a problem. Because we have to make sure, we can never allow the denominator of fraction equals 0, so that's not good. Next, if I look on the top, if I plug in 2, I get a 0 again. So really I get 0 over 0. So at that point I'm sort of stuck. However, we learned sometimes, especially in the case where you have 0 over 0, we can do a little bit of algebra and factoring and canceling, and sometimes we can actually come up with a number for the limit. One of the ways we can check, and just about the only way, is to see if things factor and cancel out. So in other words, I notice x squared minus 4 is a difference of squares. Let's go ahead and factor that into x plus 2, x minus 2 over x minus 2. Because once I factor it, then I realize, hi, I've got an identical factor in the top and the bottom of this fraction, which means they cancel. And I'm actually left with the limit as x approaches 2, x plus 2. Now if I go back and say, okay, I've got a different limit now. Let's plug in the number for this one and see what happens. If I plug in 2 for x here, I just get 4. So by factoring and canceling, I sort of eliminated the problem of when I plug in the number for x of having 0 over 0. So actually the limit of this one is 4. And the last one, the limit as x approaches negative 7. Oh, not x, t. I thought I had a typo, but I wrote it wrong. As t approaches negative 7 of t squared plus 4t minus 21 over t plus 7. First thing you always try is just plug in the number for t and see what happens. If I plug in negative 7 for t, then here at the bottom, I get a 0. Okay, so now I know I got a problem. Let's see what happens on the top. If I plug in negative 7 for t, negative 7 squared, it's going to be like 49. Negative 7 times 4 is like negative 28 minus 21. I think if I combine these, once again, the numerator is also 0. So here's another case where I have 0 over 0. Now, the only thing you can do in this case is you can see if you can factor and then cancel. If you can't do that, then you're sort of stuck. But let's see if that works here. If you can see this is t squared minus 4t minus 21. I believe you can factor that into 7 and minus 3. Of course, the denominator is still just t plus 7. And just like the previous problem, then you notice actually I have identical factors that cancel out. And by the time I'm done with that, I just have the limit as t approaches negative 7 of t minus 3. If I plug the negative 7 in here, looks like the limit is negative 10. All right. So there were a couple of limit problems. Now I'm going to number 6. And actually, number 6 has a little bit of a typo, I believe. I should fix that. Let me write it down, and then let me show you what it should have been. So like I said, this is the first time I've put together this review, so I'm unfortunately finding a few oversights and mistakes. Because what they want you to find, oh no, one typo. Because the first thing I want you to find is the limit of f of x as t, I should have put an x here. Anyways, here's what it should read. Find the limit of f of x as x approaches negative infinity Now when the notes, instead of putting x's, I put t's for some reason. And this one I call negative infinity, this one I just have to this infinity, although that's the same as positive. So hopefully everybody's able to figure that out. So basically I'm looking for the limits of these functions as x goes to negative infinity and then as it goes to positive infinity. So let's see what kinds of things we have here. Now the way I like, there's a couple ways people can do these, but here's the way I like to do these. Now these are just for limits when x is going to infinity, either positive or negative. What you do here is, I call it the leading term. The leading term is going to be whichever term has the largest exponent on your decimal. And normally these problems are written in like descending powers, x to the 5th, x to the 4th, x, and then no variable at all. The leading term is the one with the largest exponent on the variable. Because what happens is when x starts approaching infinity, x to the 5th is going to dwarf all these other values. Even though x to the 4th has exponent of 4, but still when x gets to be a really, really big number, I know it may be hard to visualize it, but x to the 4th becomes insignificant compared to x to the 5th. And negative 4x is even less significant, and 1 is really nothing. So that's why you basically say, what you do is you sort of say, I can approximate f of x to be negative 2x to the 5th. And now this is what I'm going to take the limit of. And we'll do, let me write this. We'll do negative infinity first. Now here you have to do just a little bit of thinking, because the limit is basically going to be infinity, but the thing you have to think about, would it be a positive or negative infinity? Well, if you look here, let me write this out. Obviously the negative 2 is going to be negative, so you got a negative number times x to the 5th. Now if you think this is an odd power, now what happens when you stick a negative number in with an odd exponent? When it's all done, the number is still negative. So if I'm plugging a negative infinity into x to the 5th, it's going to be a huge number, but it's also going to be a negative number. So if negative 2 is a negative number, and this x to the fifth is also a negative number, that means two negatives multiplied together is a positive. And f of x is actually going to end up being positive infinity. Now what happens when we take the limit as x approaches positive infinity? Well, in this case, the negative 2 obviously is always negative. Now if we put in huge positive numbers into x to the fifth, that's going to be positive. So in this case, we have a negative times a positive, which is negative. So in this case, the limit is going to be negative infinity. All right, so not too bad, just got to think about it a little bit. All right, that was problem A. Let's look at some more of these. Here's B. F of x equals 4x cubed minus 2x plus 10 over 2x cubed minus 10. And we're going to look at this function as x approaches positive and negative infinity. So once again, I'm going to approximate this just to be my leading terms, which means it's like the 2x and the 10 sort of go away, and I'm left with 4x to the cubed on top. Negative 10 goes away. Now in this case, if we look and do simple canceling, you notice we have a factor of x cubed on the top and x cubed on the bottom. If those cancel out, you're left with 4 over 2, which is 2. So what's interesting is, in this case, it doesn't really matter what limit you're approaching. If x is approaching negative infinity, or if x is approaching positive infinity, doesn't really matter, because you know what? This function doesn't change. It's always 2. Matter of fact, the limit doesn't really matter where you're going, either to negative or positive infinity. It's always going to be 2. And that's what happens when your leading terms have the same exponent. Then the limit ends up being the ratio of your coefficients. In other words, 4 over 2. Okay, a couple more examples. Here's another fraction, x squared minus 21x plus 100 over 2x minus 55. Once again, let's reduce this down to an approximation of the leading terms. Have x squared on the top. I like to put approximately. On the bottom, 2x. Now here, we can also do some canceling. End up with x over 2. Now, hopefully you can see the limit as x approaches negative infinity of x over 2. It's obviously going to be negative infinity. And the limit as x approaches positive infinity of x over 2 is positive infinity. And that's the case where, if we look back at the initial function, if the exponent in the top is larger than the exponent in the bottom of the leading terms, then you really have no limits, or you can say the limits are infinity. And then the last one, see if I can squeeze it in here on the page. F of x is x cubed minus 10 over 2x to the fourth minus 10. So once again, let's reduce this down to our leading terms. X cubed over 2x to the fourth, and if you cancel, you're left with 1 over 2x. Now if you think about it, if x approaches negative infinity and it's 1 over 2x, I hope you can see this denominator gets to be huge. It'd be a huge negative number, but it's still huge. And basically, eventually, it's going to approach or 0. And if we take x in the positive and look at it positive infinity, once again, this x is going to get huge. It's 1 over a huge number. It's also going to be 0. So in this case, they're both 0. All right. Let me stop this video now, and we'll continue on with the next one.